liftoff, Discovery. Welcome back.
Liftoff of mission 41B, the first flight of the orbiter Discovery, and the shuttle has cleared the tower.
The LOS TDRS.
Roger, nice to be in orbit.
3, 2, 1, 0. Liftoff. American return to base. Discovery clears the tower.
Okay, we checked all 4 systems, and there you go.
Wow! We're so lucky to be the next crew of scientists to stay in Mars' terraforming pod. We have a lot of work to do here. We actually have the next Martian year, 687 days to research the planet and test some prototypes for terraforming this planet.
Whew. If humans are going to be terraforming Mars to make it as habitable as Earth, there are a lot of variables that are going to have to change about this environment. Where do we even start?
Well, we know terraforming Mars is going to entail 3 major interconnected changes. 1, building up the planet's magnetic field. 2, building up the gases in the atmosphere. And 3, fixing this temperature. It's so cold.
Well, I'd always start with raising the temperature. I can't stop shivering inside this terraforming pod.
Agreed. Temperatures on Mars are an average of negative 81 degrees Fahrenheit. That's colder than the coldest days back on Minnesota. We'll get some respite in the summertime when it's positive 71 degrees Fahrenheit out, but in the winter it's as low as negative 220 degrees Fahrenheit.
Fortunately, this terraforming pod does shelter us from the worst of the Martian cold, but we really need to figure something out so we can at least be comfortable in here.
It's up to us to determine which boiler system we should engineer up here. For us and future teams that stay here to research Mars and test terraforming prototypes.
Let's get started right away and look at our 2 proposed boiler systems we can engineer with the materials that were sent on this mission with us. In these boiler heating systems, the basics are pretty similar. A tank of water is heated up so that the water is a higher temperature than the air in the building. The hot water is then pumped through the pipes that go throughout the building. Throughout the day, those hot water pipes release the heat into the rooms. When the water cools down, it flows down the pipe system and returns back to the tank.
In the first system, a water heater heats up a small tank of water to 39 degrees Celsius, which is 102 degrees Fahrenheit. And that warm water is pumped into a bunch of pipes that heat the terraforming pod. When the water cools down, it pumps back into the tank and gets reheated.
In the second system, it uses a large reservoir underneath the pod full of warm 30 degrees Celsius water. That's 86 degrees Fahrenheit. That water gets pumped from the reservoir into the pipes that heat the terraforming pod. Then, the cool water is pumped back into the ground reservoir to get reheated with geothermal energy.
Oh gosh, where do we even start? There are a lot of different variables here between these 2 systems that could warm up this whole space. But which one's going to do the best job in making it warm in here, and which one's going to be the most efficient?
Well, we'll need to take some time to determine where to build the system's water tank, how big to make the water tank, and how hot the water should be in the tank before we send it through the pipes to heat up the air in here.
Well, we better figure it out sooner rather than later.